Hi students, Miss Vernon here today to teach on lesson P1, which is going to cover interval notation. So we have interval notation. This is the new concept in today's lesson. And we have properties of exponents, which will be more of a review. We'll review all the rules related to these properties and then how to use these properties to simplify different exponent type problems. Interval notation we're going to teach on first, as it is the new concept that we are learning. And let's go ahead and just jump in. So with interval notation, there are two types of intervals we will be looking at. We'll look at bounded intervals and we will look at unbounded intervals. An interval notation is simply the way we write an inequality in a more simplified format. For example, in interval notation, we can write an inclusive or bounded interval such as A to B. Instead of using the inequality signs less than or equal to, you can simply write the interval as the hard parenthesis, A comma B, hard parenthesis. We call this type of interval a closed interval. It's called a closed interval because if you remember to our original way of graphing, we used a closed-in circle to graph this, and then we would connect and say any number between those two closed circles would work. The difference with interval graphing is that we use these hard brackets, and instead of writing the inequality notation, we get to write this more simplified version. Now, when the inequality is not or equal to, so in this case, the inequality is just less than, we're going to use this parenthesis bracket. This parenthesis is going to denote that it is an open interval. And open means it kind of connects to the old way of thinking where an open interval had an open circle. It means it doesn't include that point where the circle is at, but it does include everything that is in between it. We can also have what they call a half open or interval where one of the inequalities would be or equal to, and the other one would have been just less than. Now, moving forward, instead of graphing with the circles, we're going to transition into graphing with these hard parentheses or brackets and parentheses instead of the open and closed circle. And as we move forward, you're going to no longer use inequality notation and instead start to use interval notation. This is actually a concept that we will use all the way through the end of the school year. So it's very important that you understand how to use it. The other part of interval notation that's really important to understand is that the first term listed in your interval notation must be the smallest or leftmost term on your number line. So this should always be the smallest term, and this should always be the largest term. Let's go ahead and look at what an unbounded interval would look like. An unbounded interval is going to be an interval that will go on forever in one direction, not typically in both, but just in one. So here we have an example of a closed interval. It's closed because we have that hard bracket here, and it includes any value that is larger than that. I would read this as x is greater than or equal to a. Now, when we write it in interval notation, we're going to bring in that infinity symbol, and we're going to say a to infinity, which means any value that falls from a all the way through infinity is going to be an acceptable answer to whatever the problem was we were solving. The next example is, again, an open interval, but this time it is still unbounded. We have that parenthesis, and again, extending all the way into positive infinity. Notice that a is your leftmost number on the number line, and infinity is where it ends, which we know infinity just keeps going on. The last two are going to be examples where negative infinity is used. So we don't know where it ends, but the leftmost term is going to be your negative infinity, and then it stops at that b value. The third one listed here is a closed unbounded interval, and then the last one here is an open unbounded interval. Let's go through a couple of reminders, and then we'll do an example together. So a couple of reminders to have when working with interval notation. Always write the interval with the smallest value first, followed by wherever it ends. An open interval uses a parenthesis to denote this. We used to use an open circle when graphing on a number line. And a closed interval will use this hard bracket. And again, we used to use the closed or filled in circle in the old way of graphing. So that's kind of the connection behind those. And sometimes students I find like to connect those. So they might say this is used when it is a closed in circle. Then they might go ahead and say if it's or equal to, and then they will write the parenthesis with an open circle and say this is used when you're dealing with those types of inequalities. All right, let's take a look at an example together. I actually have two examples for us. We'll start with this first one. So in the first example, we are given this x is less than 4, and we want to complete all three parts below. So the first question says, write it in interval notation. So this is given to us in inequality notation. Interval notation is going to be the one that has the parentheses and brackets. So we know that it's going to have the 4 in it. And we want all values that are less than 4, which means I want the numbers that came before it. So that means I want the numbers that are going to be on this side or towards negative infinity. Now, infinity, we don't actually know where it ends. So we're always going to use a parenthesis on the infinity. And because it was just the less than symbol, we're also going to use a parenthesis here. So in this case, the answer would be parenthesis, negative infinity, comma 4, parenthesis. On the number line, practicing using that interval notation, I'm going to use the parenthesis, and then I'm going to go ahead and I'm going to cheat a little bit here and use the line tool on my computer and just extend this all the way down this way, because any value that came before it. I find that students who might be struggling with graphing these or writing it in interval notation, once they graph it, it's easier to see, okay, I want to go from negative infinity and stop at 4. And that same parenthesis that I'm using here is going to help me know that that's the parenthesis I'm using above. If I were describing this interval using words, I would say that it includes all values that are less than 4. This is an unbounded open interval. So now I've incorporated that vocabulary from class today, but also have found a way to make sure that I am just articulating all of the different parts of the interval. Let's go ahead and look at example 2. So in example 2, you'll see that I have given us an interval this time. And so the inequality, this should say interval, I apologize. And we want to rewrite it as an inequality. So rewriting this as an inequality, we would go ahead and say, well, we wanted to start at negative 4. X is going to be placed here, and we want it to end at negative 0.5. And because this is a soft bracket or a parenthesis, I'm going to use the just less than. And because this is a hard parenthesis or bracket, I'm going to use the or equal to. And so now it's indicating that this inequality will have all x values from negative 4 to negative 0.5. If I go ahead and say I want to graph this on the number line, I'm going to use the parenthesis on the negative 4, and I'm going to use a hard bracket on where approximately the negative 0.5 would be, and I'm going to connect all values right in between there. So now I've gone ahead and graphed it on a number line. Again, the last part of this just says describe the interval above. So if I were describing this interval, I would describe this interval as a closed, a half open bounded interval including the values between -4 and -0.5. We will include -0.5, but exclude -4. Again, you might have a different way of wording it. I'm just giving you an example of a way to describe the interval that you are working with. Let's go on and review our properties of exponents. So let's begin with just a really basic thing. What is an exponent? The exponent is the subscript above the base. So in this problem, 3 is the exponent, 4 is the base. And if I wrote it out in expanded notation, I'd have 4 times 4 times 4. When dealing with properties of exponents, there are a few rules we want to keep in mind. The first rule is your final answer should not have negative exponents in it. When possible, try to simplify. So for example, 4 squared is actually 16. And when you know you're done with the problem when no variable is appearing more than once in your simplified answer. So you don't want to have an x on the top and an x term on the bottom. You can do some more simplifying in that case. So let's go ahead and just review the rules here. And then there's an example showing each of the rules. Now, in general, when you're starting to work with properties of exponents, knowing the rules is great, but if you forget the rules, it's no big deal. You can always write it out and process the problem in different ways. So let's go ahead and take a look at the first property. The first property is called the product property. Now, with these properties, it's really important that you note that the bases must be the same in order to do the operation with the exponents. So in this first property, which is the product property, it says that if the bases are the same, you can add the exponents and have a simplified answer. So in our example, 5 is the base. It is the same. So they took and said 3 plus 4 is 7. So this could be simplified to 5 to the 7th. In example 2, or property number 2, I should say, this is the quotient property. And in the quotient property, again, we always want to check, are the bases the same? They are. So the quotient property says that if the bases are the same and you are dividing two terms that have an exponent, you can subtract those exponents and write it as a single term. So in this problem, the bases are both x, and they take 9 minus 4, which gives them the final answer of x to the power of 5. The third property is known as the zero property, or the property of 0. And this one just says, hey, anything to the power of 0 is 1. 8 to the 0 is 1. M to the 0 is 1. Anything to the 0 power is 1. We can take a look at that in class discussion if you'd like to know why that occurs. The fourth property is the negative power. So anytime you have a negative power, you want to send it to its opposite location. So if you think about this as being written over 1, you have a negative exponent or power on the top of it. So to make it become positive, you send it to the bottom of the fraction. Now, this also applies in the reverse. So if I had 1 over n to the negative 5th, I could write that as n to the 5th on top, and you could think of it as n to the 5th over 1 if it helped. But again, just negative exponents, they kind of switch location and where they are in the fraction. So if it's in the denominator, it goes to the numerator. If it's in the numerator, we send it down to the denominator. Right? The next two properties actually go together a little bit. These are going to be power properties, and they have different ways of applying it. But if you have a power outside and you have two bases inside the parentheses, that power is going to be distributed, so to speak, into each of them. Now that power can only be brought in if you are multiplying Or if you're dividing, you can also bring it in if you're dividing. So let me go ahead over here and I'll give you an example of what it would look like if you were dividing. So if I had m over n to the power of 5, you could write that as m to the 5th over n to the 5th. There we go. And so that power, again, got brought into both terms. But that only works when you're multiplying or dividing. All right. And then the next property, again, this is a power property. It says if you have a base to a power raised to another power, I call this the power to a power, kind of power up, you're extra strong. You're going to take those two powers and multiply them together, and that's going to give you your simplified answer. So, for example, this would be 2 times 3, which is 6. And then again, number 7 is the connection to property 5. So these two kind of go hand in hand. It works with multiplication and division. All right, at this point, what we're going to do is we're going to transition into the next part of the lesson. So you're going to have just some time to practice this and discuss this with your teacher. We'll see you on the Google Meet shortly. Bye.